Hello and welcome to the Milkrun Optimization Plus App tutorial. This app, part of LockHub's supply chain app portfolio, helps you optimize your delivery routes for the cost and time while selecting the most efficient vehicle fleet. It considers time windows and operating hours to optimize routes for multi-day long distances deliveries. Let's see how it works. To understand how to use the app, it's important to first know which data is required for your analysis. Milkrun Optimization Plus requires you to complete several tables. In the depots table, you enter the name and location of your depots. You can also specify loading and unloading times at each depot. If left empty, the value will be 0, as well as assign a time window profile that refers to the depot operating hours. The exact times are defined in the time windows table, which we'll cover later, and are linked to the depots via the time window profile ID. In our example, we have just one depot, located in Zurich. Next is the vehicles table. Start by entering vehicle types. For each vehicle type, you can define multiple available vehicles. Milkrun Optimization Plus allows you to choose between optimizing closed routes or open routes. A closed route means you define both a start and end depot for the vehicle. An open route means you define only one of these. The engine will determine the other. For example, if you specify only the start depot, the engine assigns the end depot automatically. You must define at least one depot, and any depot listed here must already be included in the depots table. Next, you define maximum capacities, as well as the maximum number of stops per route for each vehicle type. Once a vehicle returns to the depot, its load resets to 0 and it can start again. You must also set vehicle operating hours by defining the earliest start time, the latest start time, or both. The driving profile determines the speed factor used when calculating travel times between locations. The available profiles are car and truck. The speed factor lets you adjust travel speed if the system's default is not suitable. It is a decimal number between 0.1 and 5. The default is 1, meaning no adjustment. Higher values increase speed, while lower values reduce it. Next, define fixed and variable costs. Variable costs can include costs per hour, per kilometer, or per stop. You can also specify minimum and maximum travel times, maximum route distances, and the maximum distance allowed between two consecutive stops. Finally, you can assign brake profile IDs to vehicles, which we'll explain later in the brakes table. Proceeding to the pickup and delivery orders table. Here, you enter information about orders that need to be picked up or delivered. For each order, you define its name, location, and quantity by weight in kilograms, volume in cubic meters, and number of pallets. You must also assign the depot that supplies or receives the order. Optionally, you can specify a preferred vehicle type. Leaving this field blank allows any vehicle to fulfill the order. If you want multiple vehicle types, separate them with a semicolon. You can also choose how to allocate costs, by weight, volume, pallets, or a combination of these in the side panel. If you select weight, for example, but leave some weight cells empty, the program will remind you that the corresponding result will be shown as 0. This feature allocates the cost by calculating the share of each leg's weighted distance in the total route's weighted distance, where the weighting factor is the unit you choose. That share is then multiplied by the total route costs, giving you the allocated cost per leg expressed in cost unit. You can then define time constraints, such as stop duration, loading or unloading time in minutes, and time windows. The time window profile specifies the earliest and latest time the order can be fulfilled. These times are defined in the time windows table. You can also define external costs, which represents the cost of outsourcing an order. The optimization algorithm compares the cost of fulfilling the order with your own fleet versus outsourcing, helping you decide which orders to keep in-house and which to outsource. Now let's look at the time windows table. Here you can define multiple time windows. For each, specify the earliest start time and the latest end time. Note that the time window profile does not contain unique values. One profile ID can include multiple ranges. For example, time window 01 may cover December 16 at 10 p.m. to December 17 at 12:30 a.m. and also December 17 from 1:30 a.m. to 5 a.m. Time windows apply to both depots and orders. Next, the brake profiles table. Like time windows, brake profile IDs can have multiple rules. You can define exact dates and times when brakes start and end, or set relative values that define how many hours a driver can work before a brake is required. For each brake ID, you also specify the brake duration. These fields are optional, but useful for optimizing multi-day routes while ensuring driver safety. Once all data is entered, you can proceed to the calculation. Choose the duration unit you want to use and save your scenario if you would like to compare it with others later. Then, click Calculate. To analyze the results, open the map view. You can visualize routes at street level, provided there are fewer than 200 routes. On the map, you can explore all routes from the optimal solution. Toggle stop numbers on and off, adjust colors and styles, share the map with your team, or review elevation charts showing road gradients. In the dashboards, you can explore interactive KPIs for each route, such as vehicle utilization by weight, volume, pallets, distance, and time, giving you a clear overview of the solution's performance. For more detail, review the output tables. The route overview table shows vehicle types, cost, time, and distance parameters and utilization. The route details table lists information for each leg of the route and their cost allocations. The external orders table show if any shipments were dropped because they could not be served by the optimization NG. In our example, none were dropped. And that's it. You've learned how to optimize multi-day routes, select the right fleet, reduce costs and travel times. For best results, remember these tips and tricks. Always define at least one depot, start or end, for each vehicle. Without this, the optimization engine cannot build routes. Make sure all depots referenced in the vehicles table are first defined in the depots table. Use time window profiles consistently. Remember, they link depots and orders to the time windows table. When entering orders, leave the vehicle type blank if you want the algorithm to assign any available vehicle. Use the semicolon to allow multiple vehicle types. Use external costs to compare outsourcing versus in-house delivery. This helps balance costs and fleet capacity. If the system's driving speed feels unrealistic, adjust the speed factor instead of changing locations or routes manually. Use brake profiles for long or multi-day routes to improve driver safety and legal compliance. Thank you for watching this tutorial. For more information and troubleshooting tips, make sure to visit our support resources online.